Welcome to Robots in Depth. Today I'm honored to have Melonee Wise here, and we're going to talk about everything in robotics. Could you tell me how you started?
Well, I think that robotics for me has been very serendipitous, actually. I think that I always had a love of building mechanical things. I think one of my earliest exposures to building mechanical things is my dad sent me to summer camp. Well, it was like a day camp, actually, not a summer camp. But Legos and programming was the focus of the day camp, and it was this was when I was like 8 years old. So think 1989, you know. And so and you learned how to program Legos, and I was like the ambitious kid in the class. I was like, I'm gonna make a plotter. And I don't know if you remember, but they had like Lego kits where you could make a plotter and draw things, and I got overly into that. I think that I built the plotter, really fast. I loved Legos, so I was really good at building Legos very fast. And then I must have spent like the entire 4 weeks of that day camp programming the plotter to draw all sorts of ridiculous things. And I got really into just building things. And I had a very voracious appetite for just any kit that I could get my hands on. So chemistry kit, Lego kits, the Scientific America. I don't know if you, so for Christmas, I would like make my Christmas list out of Scientific America, servo kits, like the light following robots. And
I'm thinking we're seeing a trend here. We're seeing where things are going to go, right?
Yeah, but it actually is kind of funny because my viewpoint of all of that, after all of that interesting stuff that I played with, I don't think I had like the greatest guidance into what I should be studying when I got older. So I went through high school, I did what all the nerds do, and I took all the classes like calculus and advanced chemistry and all of these things, preparing me for college. Like, yes. And then I decided to become a mechanical engineer. And I had this like preconceived notion in my head that mechanical engineers build robots, right? But it never dawned on me for some reason that I should probably learn how to program.
Okay.
And so I went to University of Illinois and I studied physics, engineering, and mechanical engineering at the same time. It was very ambitious. I don't know why I did it. But all through the curriculum, there was no robotics. I was like, I want to build robots, but there's no robotics curriculum really at University of Illinois. And it wasn't until in physics engineering, they try and help you find what you're really passionate about, whether it's experimental physics, theoretical physics, so as you advance through the program, you're trying to find what you're interested in. And I took this set of seminar series on analog and digital electronics, and you could build anything you want. And I was like, building a robot. And so I started building robots again. And my best friend, Derek, and I, we were probably 19 or 20, and we just started building robots. Anything we could get our hands on. We had no money. Completely broke, and we would go scavenge parts. And our first robot we built, it was called Zippy, and it was made out of plywood and some motors that we had salvaged. But even then, there wasn't much robotics. And then at UVI, there was a group of alumni who wanted to do the DARPA Urban Challenge, and they got involved with the university, and there was this opportunity to come to California to work on this autonomous car project.
So cool, huh?
Yeah. And so I was supposed to be doing my PhD, and I was, not.
You're still in physics now, right? With the PhD.
So I was doing mechanical engineering, actually. So I did undergrad physics and mechanical engineering, and then I just kept going with mechanical engineering. But Derek and I decided on our winter break to come out to California for 2 or 3 weeks. And I ran into the person starting Willow Garage, and he was like, "I'm going to build a robot company." And I was like, "Okay, that sounds cool." And he's like, "You don't want to go back and do your PhD, do you?" And I was like, "I really should do that." And he's like, no, people with PhDs, that's not exciting. He's like, "What are you going to do? Go back and do that for another couple of years? You could be building robots right now." And I made the most risky decision I would say in my entire life. On a whim, I decided to leave my PhD program and come to California and start at Willow Garage. And I was the second employee.
Yeah, the rest is history.
Yeah,
say, right?
it
was a risky decision, but I think you're pretty
it worked
satisfied with it now, right?
It worked out, but it was so. I just can't remember my frame of mind that I just decided, yeah, I can drop everything and move to California next week. That sounds good.
Mm. But I guess that's a fit between the person who asked you and what they asked you to do. They just asked you, there was the right person asking you the right question and say, "This just fits me." Somehow you knew you were going to do that, right?
Yeah. When confronted with the possibility of entering a robotics playground,
How can you say no, right?
Yeah, I know.
It's just not going to happen, right? And I guess the guy who asked you know that, right?
Yeah.
He knows that this is a done deal, right?
Yeah.
So would you talk a little bit about, you're now the second employee, there's 2 guys, you and him there, and you're going to revolutionize the world with robotics, right?
Yeah, so actually when I started at Willow, it was me and 2 other guys. So, and it was crazy because Willow was this big building, and there were 3 of us.
Yeah, I've heard about this before, that the starting team sits there in this huge space, right?
And it was funny because we I don't know what we were thinking, but we all claimed offices on opposite sides of the building. It's like, oh, that makes complete sense. And so we were working on the autonomous car, and some of the people from U of I were still coming out to work on the autonomous car. And it's kind of funny because my best friend came out with me, to work on the car, and he got the same offer, "Hey, come work at this company." And my friend was like, "You don't know this person. I'm going to go back and get a job." And it's funny because he ended out in California very close to me, and eventually we convinced him to come to Willow Garage. But it was very different in the beginning. There were 3 of us, and then we got another person to join the team. So then there were 4 of us, and it was just so different. I can't even describe it. We had autonomous cars, and we were just we had installed command centers in the autonomous car. We had a screen that came out of the ceiling, and you could sit in the car and tune controllers and things like that as we were out in the field doing things. And it was very exciting.
I would imagine, huh?
Yeah, and at the same time, the founder also decided to start a boat project.
An autonomous boat.
Yeah. So, and they had a contractor doing that while we were doing the autonomous car project, and then eventually Steve Cousins joined, so he was the 6th employee, I think. And then that's when Willow went from a ragtag bunch of individuals kind of building autonomous car, and then there was this autonomous boat thing, to something that was starting to look more like a cohesive path forward, possibly.
So your start wasn't the garage; it was a huge space, right?
Well, so actually, what's really funny is, if you look at the original group of people, we actually started in a garage in Campbell for the autonomous car. They worked out of.
For being a car, of course you were in the garage.
Yeah,
right?
we worked out of a friend of one of the alumni's houses out of the garage, and it was kind of interesting, because it did start very humble, from someone's garage to then moving to the Willow Garage space, and then Willow Garage just grew from there.
Yeah, really, really cool. And of course, then you went from the autonomous cars into other projects for?
Yeah, so the car project and the boat project had like an interesting past. One of the things that happened with the car project is we had a DARPA site visit, and right before the visit started, one of the engineers decided to program the firmware of the car, but there was a ground loop in the circuitry, and it fried all the electronics.
So you're dead in the water,
yes,
right?
And there was no recovering. And so that was kind of the end of our DARPA days. And then many of us moved on to working on the boat project. And that was also not well managed. It was kind of like someone else was working on it, and then all of a sudden we had to take it over. And some of the things that were done on it were not awesome. For example, when the boat finally arrived and it was in the shipping container, and we wanted to take it out to work on it, we pulled it out, and all of a sudden we smelled burning. The person who had delivered the boat had wired all the solar panels backwards. And so we had to...
So as long as it was in the container, it was okay.
It was fine, yeah. And so, can you imagine two people that were getting the boat out, checking it out, and all of a sudden we smell this burning, and the only thing we could do at the time, because it was so hard to get the boat out, that we just took cutters and we cut all the wiring out of the boat because it was really starting on fire.
That's bad.
I know, it was terrible. And so the boat project was not long-lived. So
it ended when you took the boat out of the shipping container, right?
Well, we wired it all back up, and we did some autonomous test runs in the bay, because we had been working on the software in parallel with the hardware for a while. But it became apparent that autonomous boats was not our strong point either. And that's when at Willow, Eric and Keenan came and pitched, we've created this PR1. It's made out of laser cut wood, and we could take this vision of a robot and turn it into the mainframe that is the computer equivalent for robots. And that's when a lot of the really big synergies started happening at Willow Garage. Suddenly we had a very strong focus and a direction, and it was very ambitious. Like, if you look back at how it started, I remember there used to be this, I bet you could probably find the cache paged on Google. There's this page from pr.willowgarage.com where it was like the PR2 timeline. And if you look, we were going to finish the PR2 and all of Ross in 12 months. I mean, really, 12 months.
Yeah.
And it was this crazy time because people were suddenly really excited, and Willow was growing very quickly. We had gone from 4 people to 6 people to suddenly we had 15 people. And then we started the intern program then. And so the first summer, we had 15 employees and 20 interns. And so it was suddenly like this really energetic time. And many of those interns that summer went on to become full-time employees. It was just like this massive growth. And Ross was iterating very quickly, and PR2 hardware was coming on slowly but surely. And it was, all I can say is that in the first 2 years of Willow Garage, it was electric. And I don't think there's anyone who was there at that time that would disagree with that.
Magic years, huh?
Yeah, it was. I remember one of the employees telling me, if I sleep under my desk, robotics will move that much further.
Because they didn't have to commute for whatever.
Well, yeah, it was just one of those times where you felt like you could really impact robotics.
And you certainly did. The PR2 is magnificent platform, and it's really brought robotics so much ahead. So many people have started working on it, and you have an enormous depth in robotics, and this series is Robots in Depth.
Yeah.
Could we just forget all this and just talk about robotics in general?
Sure.
Where do you see us, where are we now in robotics? Maybe related to the computer industry, are we 1989, 1992? or, and then, of course, we're going to talk about the future too.
I think the thing is if you look at robotics, we're still in the infancy. If you look at the history, we were talking about robots almost 40 years before we had even the simplest robots. So that's like 1940, 1950, we had the first robots. They were
the turtles.
Yeah, the turtles, and then we jump forward 30 years. We're in the 1970s, and we have robots that take many, many hours to cross 6 feet of space. But when you look at what they accomplished, it's just mind blowing. You know, one of the things when they show some of the first shaky demos, if you listen to the video, they're like, "Oh yeah, we're communicating back to this huge mainframe that takes up this entire wall with radio," you know, and you're like, "What?"
Yeah. We're so spoiled with all the things that already work, like communication, batteries, computers on a chip, and whatever have you.
Yeah, and one of the big things that happened in between, you know, the early 1960s and the end of the 70s is that we were starting to introduce computers. And so some of the first robotic arms were run on computers. The transformation math that we use and depend on today was kind of understood during that time period, and even allowing us to start running robotic programs on the limited computers that we had. And so I think in that moment, computers and robotics were kind of constantly pushing the limits of what we were capable of. So at the same time that computers were in their infancy of some sort, robotics were kind of pushing the boundaries lockstep. And then one of the things that happened is you look at the 80s and the 90s, and all of a sudden this massive diversity happened in robotics. Whereas computers seem to be kind of driving towards the personal computer and other devices that we now rely on today. There's, you know, if you look at pictures of computers, it looks like the evolution of man. It looks like we're all going towards walking upright, and it looks like we're all running towards making tablets and phones, right? But in robots, it was like
more of the Precambrian explosion, right?
Yes, it was. It really was. Suddenly, you had people working on walking, people working on insect-like robots. You know, all of this huge diversity, and there wasn't a cohesive vision towards making a platform in robotics. And Pier 2 is one of the big platform pushes in robotics that I know of, and maybe I'm wrong. But so in between the end of the 1970s, early 80s, and 2010, we didn't move forward cohesively as a group, and that's for many reasons. We didn't standardize on hardware. Some of the hardware was innovating very rapidly, stereo vision cameras, LiDAR sensors. I mean, in computers, it was kind of like, we know what we need to make computer work. These are the input devices, these are the possible output devices, and maybe you don't need any of that. Maybe you just need the input devices and the program. But with robots, you know, even the simplest robot has almost infinite configurations when you think about it. You know, where do you place the sensors? What kind of sensors do you place? You know, how do you use those sensors? What are they sensing?
And what is the purpose of the robot? Robotics is deeper, more powerful, but it's also much harder,
Yeah, and I think the other thing is that when people look at robots and then they look at their computer, they're like, oh, my computers can do all these amazing things. But when you look at computers have had almost 30 years to evolve even the software that makes them work. And if you look at robots, there was a lot of effort into different pieces of software, but there was no cohesive vision. And when Ross came along and tied some of that together, and I wouldn't say that there weren't other frameworks that existed before Ross and that Ross is the ultimate solution, but it suddenly created a cohesive community that enabled these leaps to happen in robotics. I see 2010, when the Pier 2 and Ross were released together, as kind of a springboard in robotics. And maybe I have that vision because I was there participating in it. But I think you can truly see the impact of it. But I really feel that we're still in a very infant stage, because in all aspects of what robots can do, because even if you look at the progression of the robotic arm, let's just slice everything down to probably the one thing that is probably the most advanced in terms of what it's been doing, the tasks it's been doing, the software that we have for it. So in 1961, Unimate hits the scene. GM, they're taking very hot things out of furnaces with the Unimate arm, and that arm is not even computer controlled. It's controlled by tape or magnetic tape, right? It's just like a play and record. Fast forward, 80s, we're using robotic arms with teach pendants. We're doing some coding, right? And then we continue to do that. We continue to do that. And we continue to do that.
Yeah, no real innovation.
Yeah.
I guess the innovation was more under the hood and in the details.
Yeah.
Because to adapt it to the market, we're talking a lot of automated production in car factories and other factories.
Yeah. And so the way that we interfaced with those devices had minor evolution, between 1961 and 2014. And now we're starting to see some innovation. If you look at the UR5, they've really innovated the interface for how you interact with that specific arm, right? And so now with Ross Industrial, we're starting to say, hey, there's all this research and this information that we have, this motion planning, collision avoidance. How do we make that available to these robust pieces of hardware that we've been using for the last 40 years? I mean, we have so much more capability, but we've yet to integrate it into these systems. And how do we do that? And so I think that even in robotic arms, we kind of stagnated for a while. It wasn't, and I understand it. There's safety and all sorts of other things, and how we interact with the devices. Today is a lot easier because we have tablets, because we have faster computers, and without those things, it made it very hard to do much more than have a program logic controller that controlled these robotic arms. And I think that robotic arms are a great example of the infancy of robotic technology, and showing that we've come a very long way, but at the same time, we've only come a short way in a very long path.
So if we look at the future, I mean, cool robot you'd like to buy, and you think with your extensive knowledge in the area that somebody could actually make that work, and we could have that in 3 to 5 or 10 years, what would that be? I mean, from the vacuum cleaner robot, the lawnmower robots, people have those already, but what would be that next thing, you think?
The next thing I think is feasible, or the next thing I really want?
Let's do both. Let's start with the one you want.
The one I want, I would just love to have a robot to clean the house.
Pick up stuff, not vacuum clean, then sort in order.
Yeah. I think that's totally not achievable in the next.
What would you think would be the main challenge of if we select a very small scope, we're not do the hard stuff of deciding whether to wash this t-shirt in 40 degrees Celsius or 60 degrees Celsius, but is there any space there we could explore? Because I do want one myself too, just like you wanted.
So I think there's several key challenges to doing robots that we have in our home. Before we even talk about what the task is, and many of those key challenges are things like understanding social context, cultural context. So if you and I have homes, we most likely have a bedroom. We most likely have a kitchen. Those are simple concepts, right? So when you come home, what do you do? You take your keys out of your pocket, you place them somewhere, right?
Charge the phone, take off outdoor clothing.
Yeah. So what I do when I get home, totally different, right? So how do you semantically convey even that notion to a robot? So what does it mean for the robot to live in your home?
As opposed to any other home,
Yeah. So first there's that context, right? So say the robot we have it's the come home robot. And so when you come home, it does all that stuff for you. It has a little bin, you give it everything, and it's supposed to know what to do. I mean, it seems like a simple task, right? But how do you even start to teach the robot what it means to come home and what it's supposed to do?
It has to be inferred from my actions by the robot, because we can't expect people to program the robot.
Right.
I mean, if we could give them the manual and they program it, that might be manageable. But then we have a market of 4. So,
right.
I mean, the robot has to look at me and my behavior and deduce what I want to happen, and I understand that that's a huge challenge.
Yeah.
Do you see any progress in this domain?
I think there's some progress. There's this whole notion of semantic mapping, and now that we have the capability of dealing with very large databases, it makes it much easier, because then you can basically create a map and a database that represents your entire home, not just where things are XY, but XYZ, and understanding, and the tagging with that mapping can be much more dense and complete, because it's not just a bowl, it's a white bowl, it's made of porcelain, it has, the robot needs to know it's fragile, right? And how it interacts with that is very specific. And then this is where some of the cultural things come in. How we keep our homes is very cultural. And so I think one of the next really big barriers long term is another example of when you have a programmer designing something and then they only test it on themselves, right? I mean, and I think that challenge is so far away removed from the challenges that we're trying to solve today that I think that when you think about the idea of bringing a robot into your home in the kind of generic context, it's a very hard problem. But I think there is some medium ground. So what if I said to you, you know what, you can have a robot in your home and it'll pick up your dishes and put them in the dishwasher and wash them and put them away. But
I'll say, here's my credit card.
But all your dishes have to be bright orange.
Yeah, I'm okay with that. My wife, she'll also be okay with it. For, say the everyday life. Yeah. When we have a dinner party, not so much, but for everyday life, we are going to do that trade-off and saying that if it's that kind of a day, we're stressed, we have limited time, we'll do the orange plates and the robot will deal with it. It's a Friday evening or a Saturday evening, we'll do the nice dishes, and the robot will just leave them alone. I think if we have that choice, we're going to gravitate towards the orange plates, and suddenly orange plates are going to be the standard, and nobody knows why, right?
Yeah, well, I think that's an example of how I think robotics technology is going to make it into our everyday lives, is that we're going to make these concessions, and we already do it. People don't really want to admit it, but many people clean up for their Roomba. I mean, I interviewed, so at Willow we did need finding, and I interviewed many individuals who talked about how they cleaned up before their Roomba, or their electronic vacuum. You know, they would tuck in the tassels and they would pick up everything off the floor.
You do have to pick it up from the floor, otherwise it can't move stuff, right? Right. But if you had come to someone, you know, before this robotic vacuum came out and said, look, this little guy here is gonna vacuum your whole room, but you have to clean before you vacuum. Yeah. I mean, when you kind of defeats the purpose.
Yeah. When you think of it in the logical sense, like that seems totally foreign to us. Why not just get the vacuum out? But when you think of it if I just keep everything off the floor, every day this guy's going to run around and do this for me, and I don't have to schlep this vacuum around, you're like, oh, that seems reasonable.
Yeah, it's a thing we do together, the robot and me.
Yeah.
I understand the robot can't do everything, and I don't want to do everything. So, and I heard actually that in a family where they had teenage kids, it took the kids only a few months to realize if they kept the floor clean of stuff, the robot went in there and cleaned the room. So they did that autonomously. They just realized that instead of me saying, the parents telling them to pick stuff up, the fact that if they did, the robot cleaned their room and they liked it. So yeah, so that was the dream thing, maybe the robot that can do these things at home. Where do you see the feasible space? If I told you, here's a bunch of money, make me a robot that can be on the shelves for Christmas 2018.
Ooh.
Or maybe 19. I give you another year there. The feasible one.
I think the feasible robot is autonomous cars, honestly.
But that's not going to be on the shelves.
I know it's not going to be on the shelves, but you asked me what technology I think is feasible, and I'd like to see that a lot because
me too, of course.
Yeah, I think it'll revolutionize society in some sense.
Yeah, I mean, just from the fact that cars kill 1 million people a year worldwide, and how many get seriously injured.
Yeah, that's why I think it's very important, and I can't wait for that to happen. Let's see, something that is available in 2019.
We'll skip the production stage. We'll say when you're done with it, it's on the shelf, right? Just in
magic. Oh geez, You're
probably better equipped to answer that question than anyone in the world, right?
I just have a very hard time seeing.
It doesn't have to be general use. It could be for a particular person. I think this is the multi-billion-dollar question, right?
Yeah. I mean, the problem is that a lot of the things that you would build cost too much to the consumer to bring into their daily life.
I also think that if you had this pick stuff up cleaning robot or the clear kitchen robot with the orange plates, I think you'd be surprised how much people would actually pay for that stuff.
Well, yeah, there's lots of examples of that, like the hero robots, the Heathkit hero robots. There were more than 10,000 sold, and the equivalent price was almost $15,000. So there's some good, I guess, history for demonstrating that expensive robot kits will sell into, I guess, hobbyist / consumer markets. I mean, the sweet spot for a consumer product that you want to put on the market, it seems like the tolerance is for everyday consumer items, maybe in the hundreds of dollars. For luxury items or things that people, like TVs, I mean, the upper limit's like $5,000. And when you look at what we can deliver for that price, it's not very much.
So it still has to come down, huh?
Yeah, well, because you need economies of scale. That's the biggest problem. I think a lot of the technology that you'll see that people probably want to buy will be for specialized markets, like autonomous wheelchairs.
Less price sensitive, of course.
Those are good applications I could see, I see on the horizon. Prosthetic limbs, medical devices that we're not that price sensitive to, I think are definitely capable in the next 5 years. I don't see that as a big challenge. I think the consumer market, and I'll say this. Brian Gerke once told me that roboticists are the worst at coming up with applications for their technology. Mm-hmm. And I totally agree. I think that sometimes it's, so much of what can't be done that you convince yourself it can't be done. And so sometimes I feel like I'm a dangerous person to ask what is and what isn't possible, because I'm a pessimistic optimist.
Yeah, you look back at the time when you did that timeline of 12 months until Rossen PR2 is done, and you say, I'm thinking I'm going to add a few years to the next project. But I think also this is a very interesting insight where you have this experience, and when you do, it's like that decision of not going back to grad school and finishing your PhD. When you find that idea, somebody introduces you, you come think about it, and you say, wow, I can actually do that. Yeah. Then you're going to have a very solid footing for that feeling that you can't really articulate it and you really explain it, but you just know that that's going to be possible, and it's going to be a market, and it's going to be used, and it's going to be great, right?
Yeah, and I think some of the cynicism or the pessimism that I have is like, so today, if you want to pick up a gallon of milk accurately, how much do you think that costs?
No idea, but quite a lot of money, I would presume.
Probably
right?
$40,000, right?
Yeah.
I mean, and that's just the arm, right?
Then you need the sensors.
Because a gallon of milk's pretty heavy, and if you set that as the bar of something that you have to pick up in the home,
it's not that heavy.
It's not that heavy.
No, we've got stuff in our homes that are in that weight span.
Yeah.
This has been fantastic. Thank
definitely.
you very much. I hope you enjoyed this episode of Robots in Depth. Please subscribe, share, and visit us on robotsinDepth.com. You can also support us on Patreon. Robots in Depth is supported by Optomica and Robots Up Close. Optomica, rent anything in modular robotics and build whatever you can imagine. Robots Up Close, travel the world and see what's going on in robotics right now, up close and personal. I would also like to especially thank the organizers of the Robo Business Conference for their gracious assistance, without which this interview would not have been possible. I am Per Sjöborg, and I thank you for watching.